Section 15.2, the Zeroth Law of Thermodynamics. Now, why the zeroth law? Do we start with that? Is it like computer programming where it's zero indexing and we start counting at zero? Not quite. It turns out, historically, the other laws were determined first, but this law came about later, was discovered later. It was so fundamental that they decided they had to put it before the others. So it became the zeroth law. So what is it? Well, it gets at the idea of thermal equilibrium. So if we have two systems, A and B, we can say that they're in thermal equilibrium if there's no heat flow between them when they're brought in contact. So that's what's shown down below, where we have the diathermal walls in action. The brownish orange walls on the outside are adiabatic walls. So there's no heat flow with the surroundings. It's just the silver walls that are diathermal that would allow heat flow. But because systems A and B are in thermal equilibrium, there is no heat flow. And our best indicator of thermal equilibrium is temperature. So if there's no net flow of heat between two systems in thermal contact, if they have the same temperature, right? If they're both at 20 degrees Celsius, then there's not going to need to be a heat flow between them. This is the basis of the zeroth law of thermodynamics. So let's get to the formal statement of it. So the formal statement, the zeroth law of thermodynamics, says that two systems individually in thermal equilibrium with a third system are in thermal equilibrium with each other. So you can think of the third system as your thermometer. So if system A is in thermal equilibrium with a thermometer, and system B is in thermal equilibrium with a thermometer, right? And the thermometer has the same temperature in both cases, then that tells you if you bring system A and system B together, they're also going to be in thermal equilibrium. This is the definition of temperature. So if it seems basic, that's okay, because it's just our understanding of temperature, but in a formal statement of it. So if two things have the same temperature, not going to have any heat flow. And so that's the idea of thermal equilibrium, is basically having the same temperature. And it's an important one for solving problems, because it's useful to know if you're in thermal equilibrium, that means everything has reached the same temperature. Okay, so that's the zeroth law. On to the first law up next.